Hello and welcome to Maths with Jacob. This lesson will focus on the real number line. A special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. What is the meaning of the following? Good luck with this one. It's a little bit tricky, so be careful. The real number line. Now, I have placed the real number line here with some information on it. So let's do some reading and see what this is all about. This lesson follows on from an earlier basic introduction to directed numbers on the number line. This is an extension of the earlier video because it goes on to further explain that there are many more types of numbers existing on the real number line. The above real number line shows the origin, which is 0, that's that point there, as well as the positive direction, which goes to this direction here. So the positive direction points to the right, and the negative direction of the number line. Now the negative direction points to the left. The next slide will feature many of the important types of numbers existing on the real number line. Now here is the real number line reproduced. The first important point is the origin. This is represented by 0. It's very straightforward, and that's where we start counting. That's our starting point. Positive integers. These are all the positive whole numbers to the right of 0. So in this direction here, we have positive integers. They are the whole numbers, such as 1, 2, 3, 4, etc. Negative integers. These are all the negative whole numbers to the left of 0. Minus 1, minus 2, minus 3, minus 4, etc. Fractions. These can be positive or negative. Some examples are 3/4, minus 2/3. They can exist anywhere on the number line. Decimals. These can be positive or negative. The examples 0.45 and minus 1.25, and they can exist anywhere on the number line. Now here's a very important concept which I have mentioned in earlier videos: rational numbers. These are numbers which can be expressed in the form a over b, where a and b are integers. So there are many rational numbers on the number line. In fact, an infinite number. But these are the numbers which have an exact value because they can be expressed in the form a over b, where a and b are integers or whole numbers. We also have irrational numbers on the number line. Some of these numbers are the square root of 3 and pi. So they're just two examples, and there are many more. In fact, there are an infinite number of irrational numbers on the number line. Some important notes. First one, there are an infinite number of points on the number line, and each of them is a unique real number. That's very straightforward. So there are many points on the number line, and each of them is a unique real number. Rational numbers are real numbers and have exact values. So once you see the word rational numbers, think of exact values. Irrational numbers are also real numbers, but they do not have an exact value, which can be expressed in the form a over b. So the irrational numbers, they are real numbers. That's important. They are real numbers, but they do not have an exact rational value. So numbers like the square root of 7, the square root of 11, pi, etc. cannot be expressed in the form a over b, so they do not have an exact rational value. Now, real numbers can be ordered. So let's have a look at this first sentence. Given two numbers a and b on the number line, a is greater than b. So if a is greater than b, then a exists to the right of b. So we'll say that again. If a is greater than b, for example, let's say 7 is greater than 3, then 7 exists to the right of 3. So if you have a look at the number line that I drew earlier, that's fairly obvious. Now, this sentence here, a is greater than b means that b is less than a. For example, if 10 is greater than 4, that means that 4 is less than 10. So if a is greater than b, means b is less than a, b exists to the left of a. So if b is less than a, b exists to the left of a. 2 is less than 8, 2 exists to the left of 8. Now this is a tricky one here, but if you think about it, it does make sense. A is less than b, which is less than c, means a is less than b and b is less than c. It follows from the above statement that a is less than c. Okay, so what we're saying is that if a is less than b and b is less than c, that means a is less than c. So it follows from the above statement that a is less than c. So here's a quick example. Say you have the number 3, 8, and 9. Let's have a look at those three. 3 is less than 8, 8 is less than 9, so 3 is less than 9. That's all that's saying. A is less than or equal to b means that a is less than or equal to b. So this sign here, see that sign there? That means less than or equal to. That's a nice short way of writing it. Here's a quick quiz. Please check through the video at any time to help you. What is the meaning of the following? Horseback riding. Isn't that a cute one? A little bit tricky, isn't it? Here are the answers to the quick quiz, and please check through the video at any time. If you enjoyed this video, please subscribe on the next slide and you will receive a notification as to when the next video is available. Hope to see you next lesson.